Hey, this is Naveen and this is my presentation for the ETH India and which is Tsunami. Tsunami is a protocol for private token streaming, which is like streaming token on a per second basis but privately. So you don't know the parameters of the of a stream or the parties which are involved. That is the sender or the receiver. Sender creates the stream and receiver is able to withdraw from stream. So Tsunami doesn't store uh, any stream related storage in the contract to calculate the withdrawal amount or anything, but the receiver or the sender or like any user in general need to prove the legitimacy of their interaction. So for example, if a receiver want to withdraw a specific amount from a stream, that receiver must prove that whatever amount he is withdrawing from the stream, it is legitimate and it is the deserving amount, and that stream is intended for that receiver. So each party each user for interaction with the Tsunami must have like uh, a shielded account, which is like a shielded private key and a shielded, you can say, an address. So you need to like generate a shielded account. So for that we'll like register, which will like uh, ask you to sign and will generate a shielded private key for you. And so this is something that you need to copy and keep it secret, whether you are sender or receiver of the stream. So you copy it and you need to register it. So register is basically an event emission, which is like uh, which, which makes like a convenient thing to like manage stuff. So we confirm it, and and the transaction is successful. So like now we are like registered. So that event basically associates the particular address, the address that is like connected connected on the website, like this one. So it associates this address to your like shielded account, so that you don't have to like remember the shielded, let's say shielded public key or shielded address. You just like need to remember the address. So yeah. And for any interaction we need to like log in with that private key that was generated. So I'm gonna log in with mine that was just registered. So I just log in, I'm logged in, and now I can, as a sender, I can create a stream to a particular receiver. So I specify the rate, which is like some token per second for this demo. I've deployed an instance of Tsunami which supports like native ETH, but in general it can support any token. So this is for like ETH per second, which is like uh, which I have specified here, and you can give it a receiver address to which like party you want to stream to. So notice that this must be a registered address too for the Tsunami protocol, so that uh, the Tsunami can like pull the event data and read the shielded account, which is like shielded public key to stream to. And you can specify other parameters like when should the stream should start and when it should end. So I'm specifying for a duration of 1 hour from 12:47 to like 1:47, and it will show you the total amount that you will need to send to the Tsunami protocol for the stream. So confirm it and it will generate a snark proof, and we confirm the transaction. And transaction is successful. So a stream is created, which is like an insertion of a commitment in the Merkle tree, which represents that stream. And so this was the sender, and as a receiver, you might want to uh, withdraw from that stream after a certain point of time, right? So you need to specify the sender of that stream, because when the uh, stream was created, there is an event emitted which includes like the encrypted event data, which can only be decrypted by a shared key between sender and a receiver. So a sender can calculate it with his private key and receiver's public key, and the receiver can also like calculate the same shared secret key with his private key and the sender's public key. So you need to like specify the registered address of the sender to fetch that stream. And so in my case, the sender address was this address, which is like also registered with the Tsunami. And now as a receiver, I'm gonna log in as a receiver, which corresponds to like this address's private key, shielded private key. So like I'm like acting as a receiver. So this is the receiver's private key. I'll log in, and I'm gonna fetch this stream, which was from this sender, and that is intended for me. So I'm gonna fetch it, and you can see that 46% of it is already streamed. Total stream amount was 0.036. Start time was 12:47 and stop at 1:47, and this is the rate. And at current point of time, I can withdraw this much of ETH, which is like 0.165, which is like 46% of 0.036. And I need to like specify to what address I want the is to be transferred from the stream. So let's withdraw to my this address, which is which has like 12.2458 gold ETH. So I'm gonna withdraw to the same address, which will also generate proof and all. So I'm gonna prove that I'm eligible to withdraw 0.06165 ETH from this stream, and I confirm it. Transaction is successful. So I have like withdrew 0.0165 is from it, and you can see that I received these, that is like corresponding to that amount, to whatever recipient address that I wanted to. And which is like not dependent on the to what address I'm sending transactions from, because everything happens with the snark proof. So receiver can use whatever address it wants, or use multiple address every time the receiver withdraws. So this was the withdraw, and it also like emits an event, and it like nullifies the previous stream UTXO and creates a new one, which is also like emits an event which includes the encrypted data in it, which was like this time, since the receiver did that transaction, receiver encrypted it with the shared key with the sender, and sender can also like decrypt it and do whatever it wants, whatever the protocol allows it to. So what protocol allows it to, it can revoke that stream. So so uh, so revoke function is also for the sender, intended for the sender of the stream or creator of the stream. So we're gonna log in with this uh, creator of the stream, which is like this shielded private key, and I'm gonna log in with it, and I need to put the address of the registered receiver of that stream. So I'm gonna fetch the data related to that stream, and here it is. So 55% streamed. You can also revoke or stop the stream as a sender for to like any receiver. So what we have done is we have fetched the stream to a specific receiver as a sender, and you can see the stream data is here, 79% of it already streamed, and we can withdraw the not yet streamed amount from this stream, and you can specify the recipient address that will like receive the withdrawn tokens or funds. So it generates the proof to validate the data, and we confirm it. So what it does is it essentially pulls down the stop time to some earlier timestamp, but not in the past, so that stream stops earlier at a much earlier time. So if you like refresh the stream, you can see that it went to 94% because we like pulled the stop time to a very earlier time, and withdrew like that much amount of not yet streamed amount, and the amount that was like already streamed, the receiver will able to like get that or withdraw that because that is already streamed. So that's it. So this was Tsunami, and you can see that this is 100% stream, and now we cannot like withdraw any ease from it as a sender, or to like revoke and stop it, and everything that is related to the stream UTXO, like the start time, stop time, the rate, it remains private, and also the parties that are involved, that is the sender and a receiver. So you don't know who is streaming to which person or party. And one thing that is like quite different in this approach is that in this UTXO stream UTXO structure, you don't really change the amount, the amount field, but there is like a checkpoint time, that is that is like a field of the stream UTXO, and that checkpoint time is like moved only forward, so it goes from start time up until to stop time. And the time differences between this checkpoint and the older checkpoint determines that this determines what amount that you are withdrawing. And you like prove that you are calculating these checkpoints and the amount with the amount that is calculated with differences between the different timestamps correctly.